computing compound interest, it says if the number of compounding periods per year is finite, then the amount in an account is given by A of t is equal to P times 1 plus R over N to the NT. P is the amount of money that you invest in the beginning. R is the interest rate you invested at. T is the time in years, and you have to kind of keep track of that. And then N is the number of times that's compounded. Now, what does it mean to be compounded? Anybody know what it means to be compound? What compounding means? It multiplies back in on itself. It says what happens is that it comes to a point in time stops, it calculates out the interest, puts the interest in, the clock starts again. And then time stops, then it calculates the interest, puts the interest in, and then, but you're now getting interest on the original amount plus the added interest from the previous time it collected interest. That's why they say compounding is so powerful, because you're not only getting the interest on the original money plus whatever money that goes in on top of it. That's what all these retirement accounts are based on. It's based on the idea of compounding. And that's, by the way, true of stocks. If you happen to buy a stock which is a dividend-producing stock, if you reinvest your dividends, the next time you have dividends, it's not only on the original amount you invested, but you reinvested that money, bought more stock, so it's on the dividends as well. So it compounds that way as well. You can build wealth that way. Now, what does it mean by the number of times compounded? Well, that's the number of times that the clock stops. You could have n equal 1, and that's yearly. So once a year, it stops, does a calculation for interest, puts the money in, and then moves on. And then it won't stop again till the next year. What you run into more is this guy. This is quarterly. A lot of investments, a lot of retirement accounts operate quarterly. That's 4 times a year. It stops, puts interest in, and then the clock starts running again. You have another one that you can look at, which is n equal 2. This is what we call semi. Sometimes the word is bi-annual. Semi or biannual. That's twice. That's 2 times a year. One you run into most often is quarterly. By the way, you could have n equal 12. I think your book has some of that. That's monthly. You could have daily. That's 365. At the end of every day, it stops, does a calculation, puts interest in, and moves on. But you don't see much of that. So it's a plug and chug problem. So I'm going to come down to the second formula, but let's do a problem first. It says, find the amount that results from $12,000 invested at 7%, compounded quarterly, and I wanted to change this. And this says for a period of 9 years. Well, what we get is T is 9 in my formula I'm going to be using. N is 4. R is the rate. It's 0.07, so you change the percents to a decimal. And P is the original amount, is 12,000. Now you need your calculators. There's no way around it for this stuff. So the formula, because it is a numerical compounding, says this, that A of T equals P times 1 plus R over N to the NT. It becomes a plug and chug. T is time, T is 9. So A of 9 equals P, which is 12,000, times 1 plus R, which is 0.07, divided by N, which is 4, to the 4 times 9. Now, when I put this into my calculator, by the way, instead of putting in 4 times 9, I go ahead and multiply that and put it in as 36. That makes the errors much less a chance of happening as it might have otherwise. And I just lost my notes with all the answers. Okay. So what would this be? Well, 12,000 times 1 plus 0.07 divided by 4 to the 36. Well, I'm off by 1,000. One thing you always have to be careful of is that you put in enough zeros. What did you get, 22,408? Yep. Okay, 22,000, make sure this is what you're getting, 408.89. Everybody get that? Let's try again. Find the amount that results from 480, 16%, 5 years. Compounded monthly. So let's see, 480, that's P. 16%, that's R. Monthly, that's N equal 12. 5 years, that's T equal 5. So now you plug and chug it into the formula so that you're now looking at A of 5 is equal to 480 times 1 plus 0.16 divided by 12 to the 12 times 5. 12 times 5 is 60, right? So this is going to come out to be hopefully $1,062.63. $1,062.63. That's not too bad. It's more than doubled. But where are you going to find 16%? That's what the problem is. Right now, your interest rates, you're lucky if you can get 2.5%, and that's good. Get 2.5%. Now you come down to the next one, and we've got something going on that's a little different, so we're going to have to take a look at it. Find the amount that results from $10,000 invested at 5% compounded continuously. We don't have an N. Well, that means what we have is a different formula, and that's this guy up here. This guy is for continuous compounding. Anytime you look at that, see the word continuous, think about, I say to myself, it's the E formula. It's any time you use it. And it says A of T equals PE to the RT. P is the initial amount, R is the interest rate, T is time in years, and then we'll talk about what continuous compounding means. People continuously compound. what that means is things don't stop. So think about births. If people had to wait and you could only have a baby at the end of every month, right? Everything comes to a start. Okay, it's time to pop out a baby. If you're going to have a baby and time is up, you pop it out at the end of the month. That would be essentially finite compounding. You would use the other formula. But what happens is every single breath we take, somebody's being born. It is happening all the time. It's like the wheel is going round and round. It never stops. That's continuous compounding. It's just going on every single second. Never stops to do the calculation. So that means it's the E formula. So when I come down to do this problem down here, where it says 10,000, that's easy, that's P. 5%, that's 0.05, that's R. Then it says continuous compounding. Then I say to myself, it's the E formula for a period of 6 years. And 6 years is T. Now what I'm looking at is this. A of 6 equals P E to the R T. So 10,000 E to the R times T $13,498.59. So $13,498.59. Now this is where you're going to have to be very, very, very careful. And it depends upon how your calculator is set up. Is that you make sure that you have that exponent on E in parentheses, so that it knows that it brings everything up. Otherwise, you could find yourself taking 10,000 E to the 0.05 and then multiply the whole thing by 6. Then it's 6 times bigger than what you, and you wonder what happened. So you have to be very, very careful to make sure that when you're doing exponents like that, you got the dang thing in parentheses.